Okay, Bismillahirrahmanirrahim. This will be the second part of our lecture that was the magnetic properties of the material. So, first of all, just let me share the screen. Okay. Today we'll start from article number 8.2, that was the magnetic material classifications. So, I will also provide you with the lecture notes, that means the Bull Professor lecture notes. So, that one is a very good in a sense of that one is described in a summarized way. Okay, so magnetic materials classification, this one is that means almost a theoretical concept based. That one means the magnetic materials can be classified in the five distinct groups. That one is the diamagnetic, then next one is the paramagnetic, ferromagnetic, antiferromagnetic, ferrimagnetic. Okay, so the total summary will be given in the article number 8 point sorry, table number 8.2. So first one will be article number 8.2.1, that was the diamagnetism. So you can go through this diamagnetism. I am not explaining. So if you go to this table 8.2, then you will find the relationship between this. What will be the limit of this psi values? What will be the uh, relation of this psi value with the temperature and this sort of thing. So similar way, you can also find this one is the paramagnetism. So most of the things are basically depends on the value of the psi. Okay. So next one will be the ferromagnetism, and the next one will be the antiferromagnetism. Next one we will find that the ferrimagnetism. Look, now if I go to the lecture note of these word professors, then you will find the lecture number 25. So before their things, if I move to the uh, previous lecture, that means the magnetization. So first of all, he has summarized the magnetic dipole moment with one-dimensional concepts. Then the magnetic dipole moment, that one is described with these three energy field. Then the external field. Then the atomic magnetic moments. So we have described these things in our previous lectures. Then atomic magnetic moments. Then the precessions, magnetizations. Again, the that is the three-dimensional magnetization, the magnetic dipole moment, then the surface current, and we have concluded that M equals to I, that means surface current per unit length, and the magnetic moment, these two are equal, that means the magnetization, these two are equal. Then we have described the magnetic field intensity and the uh, that means the magnetic field, the relationship between this magnetic field. After that, we have described about the magnetic permeabilities, the magnetic susceptibilities, this sort of thing. Now move to the article lecture 20, his lecture, 25. That means the classifications. So we have described these five types of classifications. Then in the table wise, that means everything depends on this psi values. If the psi values is negative and is small, like minus 10 to the power minus 26, then this one is known as the diamagnetic materials. Next, if that one is paramagnetic means that means the psi m value is positive, and this uh, should be small as 10 to the power minus 5 to 10 to the power minus 4, and the temperature is independent. In this case, that one is the paramagnetic, and the ferromagnetic is positive and very large value. Then that one is known as the ferromagnetic. Antiferromagnetic means that one is positive, but the value is very small. Then that one is the antiferromagnetism. And ferrimagnetic means the psi value is positive and also in a very large scale. That one is known as the ferrimagnetic. So if you just go through this table, you will learn the difference between these five types of magnetic materials. Then uh, origin of this ferromagnetism. So if I move to book, then we will find article number 8.3. ferromagnetism origin and the exchange interactions. Okay, so this one is also described in the origin of the ferromagnetism. That means we know that the Hund's law, electron will move in one single direction. After that, move in the next direction. So from there, you know about the board magnetons. And next one is, so here they have described just how this ferromagnetic thing comes, and the that means the energy level higher, the electron moves from how the electron moves from higher energy level to the lower energy level, this sort of thing. Okay. So I think if you go through, you can easily learn these things. Next, try to solve the example number 8.3. Next one is that the saturation magnetism and the cool temperature. So you know about this cool temperature. So there is a certain temperature, that means a high temperature. When if we increase this temperature, then the properties of the magnetism, that one is losses. That temperature is known as the cool temperature. Okay, right? So if we use the cool temperature, then in case of iron, you look in the x direction, that one is T divided by Tc. That means the ratio of the cool temperature and the uh, temperature effect. That means the magnetizations in for certain temperature. So the ferromagnetic behavior disappears. That means the at cool temperature, this magnetic properties disappears. Then the this ferromagnetic properties moves to the paramagnetic. Okay. No, the next one is the magnetic domain. So you know that there are two poles. That one is North Pole and South Pole, and in pyramid of this thing, there is where magnetization is in. So if we have two wall, that means side by side, that is 180 degree phase shift. That means just beside a North Pole there is another South Pole. So there will be that means just beside one magnet, there will be another magnet. There is a shift of 180 degree. So what is magnetic domain? So magnetic domain is the region of the crystal in which all the spin of the magnetic moments are aligned to produce a magnetic moment in one direction. Sorry. Okay. Then the extremely applied magnetic field. So if we applied huge magnetic field, then there will be different types of magnetic domain will exist. Then is the direction and anisotropy. So you can, I think, you know about these things. Okay. So the next one is the saturation magnetism and the full temperature. You can go for this thing. Okay. So now if we look our syllabus, then we have completed the magnetic moment, magnetization, relative conductivity, different types of magnetic materials, origin of ferromagnetism, and the magnetic domains. So now the last lecture will be based on the soft and hard magnetic materials and the ferrites. Okay. So I have also shown this magnetic domain in the lecture note of the great professors. You can also go through these things. Then the magnetic anisotropy. Okay. Okay. So try to solve the numerical problems. Okay. No need to go through this sort of things, because this one is not included in our syllabus. I think all of you know about the hysteresis law. So the next or the last lecture we learned from the article number 8.6, that was the soft and hard materials. Okay. So this one will be the end of our this part. So thank you.